Experiment 4. Oh, wait. Experiment 4, specific heat of aluminum. Some materials you'll need: aluminum rods, 2 thermometers, a 400 milliliter beaker, a hot plate, and a styrofoam cup. The procedure. First step is to fill a 400 milliliter beaker, about 2/3 full of water. Then you want to determine the mass of around 2 to 3 pieces of aluminum metal. And in this case, I'm going to use one of those weighing boats, those plastic weighing boats on the left of the balance here. I'm going to put it on the balance. Then I'm going to tear the balance to take that weight away, and then put my aluminum pieces on. And that's just good etiquette to help keep the balance clean. So you, in general, don't want to put a chemical directly onto the balance. And that would be your mass of aluminum. You can see where to write that in the data table. Then place your aluminum rods into a large test tube and gently lower it into the water bath. Now first, you have to create a water bath. So you want to put that onto a hot plate, the water that you poured into your 400 milliliter beaker, and heat it up. Then you can place your aluminum rods into a test tube. And you want to pick up the test tube with a test tube holder. You can see that clamp right there. Then you can set it into the 400 milliliter beaker. And you allow the water bath containing the metal object to boil for 10 minutes so that the temperature of the aluminum will equal the temperature of the water surrounding it. So while that metal is heating, during those 10 minutes, you want to obtain a styrofoam cup and determine the mass. And this is your calorimeter. You can see where to write that mass on your data table. Then you want to add 40 milliliters of water into the styrofoam cup and determine the combined mass. Now I'm going to measure out 40 milliliters using a graduated cylinder. That's that column there. And at first I'm going to use a funnel so that I can pour most of the water in without spilling it. Then I'm going to squirt the rest in. That gives me more precision toward the end. So I'll pour that into the styrofoam cup and determine the combined mass. And you can see where to write that on your data table. Then you want to record the temperature of the water in the styrofoam cup, and this is going to be the initial temperature of the water. Make sure you leave the thermometer in the water, that it's completely submerged, the end of it is completely submerged, and you leave it in the water for a minute or so. Alright, now you want to record the temperature of the boiling water, and this is going to be the same as the initial temperature of the metal. Then you want to carefully remove the aluminum from the boiling water bath and quickly place the metal object in the water in the styrofoam cup and place the cover on top of the calorimeter and gently swirl. After around 5 minutes, you want to use another thermometer to record the highest temperature reached after that 5 minutes. And that'll be the final temperature of both the water and the aluminum. You can see where you would write that number in your data table. Finally, dry off the metal. You're done with your first trial, and you just repeat those steps to get your second trial. And don't forget to clean up. In terms of the calculations, your book breaks it down into steps. To get the temperature difference in the water, you'll take the final temperature of the water and the metal, you can see where that is on the data table, and subtract the initial temperature of the water in the calorimeter. You can see where that is on the data table. For step 2, to get the temperature change for the metal, take the final temperature of the water in the metal and subtract the initial temperature of the boiling water. You can see where that is on the data table. For step 3, the heat gained by the water, you take the mass of the water and multiply by the change in temperature of the water. That's the answer you got from step 1. This right here, delta T of water, that's the answer from step 1. And you multiply it by the specific heat of water, which they're giving to you here is 1 calorie per gram degree Celsius. For step 4, the heat gained by the water is equal to the heat lost by the metal. So here, Q of the metal equals your answer for step 3, just with a negative sign in front of it. For step 5, the specific heat of the metal, They give you the equation. The heat on top, that heat is your answer from step 4, so Q. The mass is the mass of the metal, aluminum. You can see where that is on your data table. And the delta T of the metal, that is your answer for step 2. So I hope this helped. Thanks so much for your attention.